So now let us do the next problem. Okay, here the question is find the Laplace transform and the ROC of this given signal x of t is equal to e raised to minus 3t u of t plus e raised to minus 2t u of t. Okay, so before I start with this problem, let me tell to all of my students that it's better that you just pause this video and try to do this by yourself. Okay, just try to do this by yourself and see where you're getting stuck, or see what is the difference between my answer and your answer. That is the perfect way to learn. Okay, learn by doing by yourself. All right, so now let's continue with the problem. As you all know, the first thing I do is I write the Laplace transform equation. That is, the Laplace transform of x of t is nothing but integral minus infinity to plus infinity x of t into e raised to minus st dt. Now I substitute the value of x of t in the given equation. That is, this becomes minus infinity to plus infinity. What is x of t? It is e raised to minus 3t u of t plus e raised to minus 2t u of t into e raised to minus st dt. Okay, this is also equal to integral from minus infinity to plus infinity. I can say that this is e raised to minus 3t u of t into e raised to minus st plus integral minus infinity to plus infinity e raised to minus 2t u of t into e raised to minus st dt. Okay, like I said before, u of t is 1 when t is between 0 to infinity. Otherwise, u of t is equal to 0. So, since u of t is equal to 1 from 0 to infinity, the time t becomes 0 to infinity, e raised to minus 3t into 1 into e raised to minus st dt plus integral 0 to infinity e raised to minus 2t into 1 into e raised to minus st dt. Okay, this is also equal to integral 0 to infinity e raised to minus s plus 3t dt plus integral 0 to infinity e raised to minus s plus 2t dt. So you will get this expression. Okay, so now, like I said before, this is the perfect time to find my ROC. Alright, so since here there are two terms, then for each of these two terms there are two ROCs. Okay, if you look at the first term, here you can see that as I said before, the power of the exponential must be negative. So there's already a minus sign over here. Therefore, the real part of this power must be negative. That means, in other words, sigma plus 3 must be a positive value. Okay, so therefore sigma must be greater than minus 3. This is the ROC of this term. This is the ROC of this term. Okay, and the ROC of the second term is here sigma plus 2 is greater than 0. Here also the power must be positive, since there's already a minus sign over here, so the power must be positive. So sigma plus 2 must be greater than 0, or in other words, sigma must be greater than minus 2. So this is the ROC of the first term and this is the ROC of the second term. Okay, so what is my overall ROC? That means, what is the ROC of the given question? That is what you should understand. So here you should understand that here, if you look at the values of the sigma, that is, here sigma is greater than minus 3. This is the ROC of the first term, and ROC is here is sigma is greater than minus 2. That is the ROC of the second term. Okay, so my overall ROC should be such that it should satisfy both my conditions. It should satisfy this ROC and this ROC. So the ROC that satisfies both of these two ROCs is my overall region of convergence. That is, here the value sigma is greater than -3 and here sigma is greater than -2. So looking at these two values, you can immediately understand that that one ROC actually covers the other ROC also. That means here all the values that are greater than -2 are also greater than -3, right? And all the value and not all the values that are greater than -3 is greater than -2. For example, if you take -2.5 is actually greater than -3, but it is less than -2. You see? So that means this ROC covers both these conditions, which means that my overall region of convergence is sigma greater than -2. This is my region of convergence of the given question. Okay, now we'll continue with our problem as usual. Here the Laplace transform of x of t is equal to -1 by s plus 3 into e raised to minus s plus 3 t from 0 to infinity plus -1 by s plus 2 for e raised to minus s plus 2 t from 0 to infinity. This will become -1 by s plus 3 into, here is e raised to minus infinity minus e raised to 0 plus -1 by s plus 2 into e raised to minus infinity minus e raised to 0. E raised to minus infinity is 0 and e raised to 0 is 1. So therefore the answer here becomes 1 by s plus 3 plus 1 by s plus 2. On cross multiplying, you will get s plus 2 plus s plus 3 divided by s plus 3 into s plus 2. Okay, so this is also equal to 2s plus 5 divided by, here if you multiply these two denominators, you will get s square plus 5s plus 6. This is my Laplace transform of the given question. And here my region of convergence is given by sigma greater than -2. Okay, so now I am going to plot my region of convergence in the S-plane. This is sigma, y-axis is j ohm 0. This is my S-plane, and here is my value -2. So sigma must be greater than -2. Therefore, my region of convergence, this is the value of sigma, and my region of convergence is this entire shaded region, that is from -2 to plus infinity. Okay, I think now is the perfect time to tell you what is poles and what are zeros. It's simple, just simply look at the fraction over here. Okay, poles means the value of s at the numerator. Just simply equate what is on the numerator to 0 and find the value of s. That is how we find the value of, that is to find the value of zeros. To find the value of zeros, just simply equate the numerator to 0. Okay, so here 2s plus 5 is equal to 0, therefore s is equal to minus 5 by 2, that means s is equal to minus 2.5. That means here my 0 is over here. This is my 0, minus 2.5. Okay, and you can also mark the poles. Poles means the value of s at the denominator. Simply equate the denominator to 0 and find the value of s. So here there are two factors, that means there are two poles. So that means here s is equal to -3 and here s is equal to -2. So just simply mark -3 and -2. This is -2 and this is -3. Okay, so this is how we do the problem.